To help consumers assess the risks they are taking, the FDA publishes the amount of nicotine found in all commercial brands of cigarettes. A new cigarette has been marketed. FDA tests on this cigarette give a mean content of 24, nicotine content of 24.4, and a standard deviation of 2.5 for a sample of 9 cigarettes. The FDA claims that the mean nicotine content exceeds 27.3 for this brand, and their stated reliability is 95%. Do you agree? So, for the sample of 9 cigarettes, they got the mean nicotine content to be 24.4 milligrams. So now, to make the claims about the population, we need the confidence interval. And when means are involved, we use t-stats to get the confidence interval. So let's first find the confidence interval here. So n is 9, that's the sample size, and the mean is 24.4, and standard deviation is 2.5. And you need the 95% confidence interval. So let's go do from the beginning. Stats, t-stats, one sample with summary. So sample mean was, what was it? I already forgot. Let's see. 24.4, standard deviation 2.5. 24.4, 2.5, and the sample size was 9 cigarettes, and you wanted a 95% confidence interval. So it tells us that for all the cigarettes, not just those 9, but all the population of cigarettes, the nicotine content is between 22.47 milligrams and 26.32 milligrams. So between 22.5 and 26.3, 22.5 and 26.3. So they are making the claim that it exceeds 27.3. No, 27. It was between 22.5 and 26.3, so it can't be. I mean, it can be greater than 27.3, but you can't claim it based on the data. So no, I don't agree. 27.3 does not fall in the confidence interval. You're right. Confidence interval was between 22 point something and 26 point something. The GPA of 12 randomly selected college students are shown. Assume population is normally distributed. Find the sample mean. So now this is the data. Remember, we have been using with summary, but there was also an option with data. And now this is the sort of situations where you would use the with data. But the first part of the problem is the sample mean. That is a much earlier topic. So remember how we did the sample mean, open in StatCrunch. And the command, if you remember, for the sample mean was stats, summary stats, and columns. You select the column and compute, and the mean, where is the mean? 2.333. Standard deviation was all, sample standard deviation was also there. Remember, the standard deviation and the variance are the sample ones. If you want the population ones, you have to get the unadjusted standard deviation and unadjusted variance. The default ones are for the sample. So 1.1 1187. 1.1187 would be 1.12. So that was old stuff, and now we come to the stuff of this chapter, the 95% confidence interval. And you know that for this you have to use t-stats. And now what you will do is you have the data copied already, and so you will do, but okay, let's do it again. So copy the data in StatCrunch, and you want the 95% confidence interval. So you will do stats, t-stats for the confidence interval for means, one sample, and this one is with data. You select the column, you select the confidence level, and that's it, you compute. So 1.623 and 3.044. 1.623 and 3.044. 1.62, 3.04. Yeah, so actually this with data is much easier. All you have to do is to copy the data and choose the confidence, and everything else the StatCrunch does itself. Whereas if you're doing with summary, then you have to enter some information.